Hello, and welcome to our introduction to Six Sigma, and specifically the information and knowledge needed for the Yellow Belt certification. Six Sigma is a popular and effective methodology to assist businesses to improve products and processes. The body of Six Sigma can be deep and wide, and depending on your particular product and the industry you're in, the use of the many tools will vary. If the body of knowledge of Six Sigma were a large pool 12 feet deep, we will be dipping our toes in the pool. Many of the concepts we will discuss today may be new to you. You will learn new definitions, terms, acronyms, terminologies, and concepts. If you find this interesting and profitable, we offer more in-depth courses in Green Belt and Black Belt certifications. Without further delay, let's get started. Here is the course outline for reference. Evolution of Six Sigma. What is Six Sigma? Goals of Six Sigma. Six Sigma approach. Why do organizations adopt Six Sigma? Six Sigma mathematical interpretation. Roles in Six Sigma organization. Key stakeholders. DMAIC cycle. We will begin with the first chapter, Evolution of Six Sigma. The concept of Six Sigma evolved progressively over a period of 2 decades in step with concerns of organizations worldwide for quality, value creation, and customer delight. The phases of this evolution can be identified concurrent with the emphasis placed on these 3 critical business parameters. The timeline can be approximately summarized as follows. Now we will move on to the next chapter of What is Six Sigma? As far as the definition of Six Sigma goes, it is a data-driven, customer-focused, and results-oriented methodology which uses statistical tools and techniques to systematically eliminate defects and inefficiencies to improve process. The salient characteristics of the Six Sigma methodology are: it is customer-centric, it is product and process-focused. Six Sigma projects are data-driven and fact-based. Six Sigma implementation leads to breakthrough performance gains. It leads to structured improvement deployment. Six Sigma stresses validation through key business results. Now we will look at the goals of Six Sigma. The most prominent goals of Six Sigma are enhancement in customer satisfaction, elimination of defects, improvement in yield, reduction in variations, strengthening of the bottom line. Here's an example to illustrate the goals. GE's Medical System Division, GEMS, used Six Sigma design techniques to create a breakthrough in medical scanning technology. Patients can now get a full body scan in half a minute versus 3 minutes or more with the previous technology. Hospitals can increase usage of their equipment and achieve a lower cost per scan as well. So what is the Six Sigma approach? Six Sigma approach is to find out the root causes of the problem, symbolically represented by Y equals F sub X. Here, Y represents the problem occurring due to causes X. Let's move on to the chapter on why organizations adopt Six Sigma. Organizations embrace Six Sigma because this approach systematically and measurably enhances the value of the organizations by making them competitive, quality-conscious, customer-centric, and forward-looking. Some of the benefits that the organizations derive from Six Sigma initiatives are waste prevention, defect reduction, cycle time reduction, cost savings, market share improvement. In our next chapter, we will learn about the mathematical interpretation of Six Sigma. Sigma, represented by the Greek alphabet letter sigma, this letter stands for standard deviation from the mean. Six Sigma represents 6 standard deviations from the mean, where USL, upper specification limit for a performance standard, any deviation from this is a defect. LSL, lower specification limit for a performance standard. Any deviation below this is a defect. Target. Ideally, this will be the middle point between USL and LSL. Details will be provided in our Six Sigma Green Belt and Black Belt course. Process standard deviation, sigma, should be so minimal that the process performance should be able to scale up to 12 sigma, 6 sigma each on either side of the origin on the x-axis, within the customer specification limits. Let's take a look at a table illustrating the sigma level, defect percentage, and resultant situation for different industries. Sigma level 3, 6.6807%. 7 hours of no power supply per month. 15 minutes of unsafe drinking water per month. Sigma level 4, 0.6210%. 500 incorrect surgical operations per week. 20,000 incorrect medical prescriptions per year. Sigma level 5, 0.0233%. 1 wrong landing of airplane per month. 200 letters lost by day in the mail. Sigma level 6, 0.00034%. 1 minute of unsafe drinking water supply every 7 months. 1 hour of no supply once in 34 years. 1.7 incorrect surgical operations per week. 68 incorrect medical prescriptions per year. 10 letters lost by month in the mail. It is important to note that as the sigma level increases, the defect percentages decrease, which improve the efficiency of the process. Moving on, let us look at the roles in Six Sigma organization. The major roles are as follows: executive leadership, champion, master black belt, green belt, project team, and team members. Let us learn about each role in detail. First, we will consider executive leadership. This role includes project sponsors and process owners. They create the Six Sigma vision for an organization. They are responsible for ensuring that everyone in the organization understands the vision and all work with unity of purpose to realize it. The next role under discussion is champion. Champions are selected by executive leadership or senior champions. They organize and direct the initiation, deployment, and implementation of Six Sigma throughout the organization. They ensure that Six Sigma is properly implemented in the business activities of the organization. Champions can be either deployment champions or project champions. Next in line are the Master Black Belts, who are in-house experts selected by champions. They manage project selection and human resource training with the help of champions. They train black belts and green belts in Six Sigma implementation. Next are the black belts. They apply the tools, techniques, and knowledge of Six Sigma principles to a given project of an organization. They are responsible for accomplishing the tasks entrusted to them by champions and executive leadership. They dedicate all of their work hours to Six Sigma implementation. After black belts, we have the green belts. These individuals implement Six Sigma while discharging their other assigned duties. Green belts have fewer Six Sigma responsibilities than black belts and master black belts. They dedicate only a part of their work hours to Six Sigma implementation. The last rung belongs to the project team. These are team members who work on the Six Sigma project. It includes the project manager as well. Project team members need not be a green belt or black belt. Now let us see who are the key stakeholders in a Six Sigma project. The first stakeholder is the customer. Customers are very important stakeholders whose requirements have to be considered throughout the project cycle. Then comes the employees. These are the people involved in the Six Sigma initiative in the organization. Next are the suppliers. They are people who provide inputs to the process. Finally, we have the end users. They are people who actually use the product or service. End users can also be customers. In the next chapter, we will look at an overview of DMAIC. DMAIC is a data-driven Six Sigma process for improving existing products and processes. The DMAIC process should be used when an existing product or process requires improvement to meet or exceed the customer's requirements. This initiative should be consistent with the business vision, strategy, and goals of the organization. The examples of companies using DMAIC methodology are GE, Motorola, and many others. GE uses DMAIC to reduce invoice defects and disputes by 98%, speeds up payment, and creates better productivity. Let us see what exactly DMAIC stands for. D stands for define the problem. M is to measure the outcome. Y to determine the current process performance baseline and validate the measurement system. A is for analyze. Identify X's, root causes of the defects, variation sources. I stands for improve the process by eliminating defects. C means to control X's for sustained performance. Now we will look at each of these phases. Each of these phases has inputs, tools, and outputs. The inputs of the define phase are need for a Six Sigma project, executive management sponsorship. The tools used in this section are organization hierarchy, high-level process maps, high-level Pareto charts, idea generation and categorization tools. The outputs of the define phase are project charter, established metrics, problem statement, roles and responsibilities. The next phase is measure. The inputs here are project charter, roles and responsibilities, problem statement, stakeholder requirements, established metrics. The tools recommended for this phase are data collection tools and techniques, detailed process maps, cause and effect diagrams, flow charts, brainstorming, statistical distributions, probability, gauge R&R study. The expected outputs are well-defined processes, baseline process capability, process parameters affecting CTQ, critical to quality, cost of poor quality, COPQ, measurement systems. The next phase stated is analyze. The inputs for this phase are well-defined processes, baseline process capabilities, process parameters affecting CTQ, critical to quality, cost of poor quality, COPQ, measurement systems. The necessary tools here are failure mode and effects analysis, data analysis, hypothesis testing. The outputs of this phase are important causes of defects, performance gaps, special and common causes of variation, cost and benefits of proposed solutions, points of failure. In the improve phase, the inputs are important causes of defects, performance gaps, special and common causes of variation, cost and benefits of proposed solutions, points of failure. The tools required in this phase are solution design matrix, design of experiments, Taguchi robustness concepts, response surface methodology. The outputs of the improve phase are cost and benefits of different solutions, process capability of proposed solutions, selection of solutions for implementation, implementation plan. The last phase is control. The inputs of this phase are cost and benefits of different solutions, process capability of proposed solutions, selection of solutions for implementation, implementation plan. The tools used are data collection methodology, control chart, 5S, Kaizen, Kanban, total productive maintenance, cycle time reduction, measurement system reanalysis. The outputs of the control phase are implemented solutions, revised measurement systems, control plans for sustaining benefits, improved process capabilities, and lessons learned. Let's learn about each phase in detail. The define phase is used to identify areas to improve. and defines goals for each improvement activity, and ensures that resources are in place for the improvement project. The define phase focuses on customer requirements and identifies projects' CTQs, critical to quality. Each CTQ is a product or service characteristic that satisfies a customer's requirement or process requirement. The measure phase evaluates the process of determining the current process performance. This is the baseline. It uses exploratory and descriptive data analysis to help understand the data. The measure phase allows you to understand the present condition of the process before you attempt to identify improvements. The inputs to the measure phase are the outputs of the define phase. The analysis phase is used to identify a few vital causes from a list of potential causes obtained from the measure phase that actually affect project outcome using Six Sigma methodologies. The data collected in the measure phase are examined to determine a prioritized list of the sources of variation. The improve phase of Six Sigma is used to improve the system to do things better, cheaper, and more rapidly by finding the optimum solution for why, implementing the new approach, and validating it using statistical methods. The main objective of the improve phase is to improve the process by eliminating defects. The control phase of Six Sigma is used to develop and implement the process control plan to ensure continuance of the improved process. The major activities of the control phase are to validate the measurement system, verify process improvement, and develop a control mechanism. Before arriving at the control phase, we have identified the best settings for each of the vital X's. The key now is to ensure that the X's do not drift from their targeted settings. Process control is an important tool to ensure that the Six Sigma project delivers lasting benefits. With this, we come to the end of the session. We hope you've enjoyed it. Thank you for watching.